In this example, we are asked to graph the set of parametric equations by making a table of values. We have x is defined as equaling t squared minus 2t minus 3, and y is equal to 3 minus 4t. We are also given the restriction that t is greater than or equal to 1, which means that the lowest value of t that we can use in order to find x and y coordinates here is 1, and then we could use any other larger value beyond that. What that also means is that the resulting curve that we are going to have will have a starting point wherever the first time is, which is time 1. However, once we identify the trend, it will continue infinitely along that trend. So it'll have a starting point and will go on infinitely. Kind of like a vector, but a curve instead. In order to do this one though, this is more algebra than it is trig. We just need to make a nice t-table here in order to get values of x and y. And we'll go until we have enough. I will start though with 1 for sure, and probably just whole numbers after that should probably be sufficient. 3, 4, we'll see if we have to do 5. If I plug in 1 into t for the first equation, that'll give me 1 squared minus 2 times 1 minus 3, or just 1 minus 2 minus 3. That will give us overall negative 5 for x. And then if I plug in 1 for t for the second equation, that'll just be 3 minus 4 times 1, or 3 minus 4, which is negative 1. Then if I plug in 2 into t for the first equation, that will give me 2 squared minus 2 times 2 minus 3. Or 4 minus 4 minus 3. Overall giving me negative 3. Next we have, if I plug in 2 into t for the second equation, that'll give me 3 minus 4 times 2, or 3 minus 8, which is negative 5. Then I could try plugging in 3 now. 3 squared minus 2 times 3 minus 3. That is 9 minus 6 minus 3, which actually overall comes out as 0. Then if I plug in 3 for the second equation, I get 3 minus 4 times 3, or 3 minus 12, which is negative 9. This will probably be the last point that I plug in, as we probably will see the trend from there. 4 squared minus 2 times 4 minus 3. That's 16 minus 8 minus 3, which is overall 5. And then 3 minus 4 times 4 now. That's 3 minus 16, which is negative 13. So let's see what this would look like. Again, keep in mind that we will plot in order based on the time of t. If, for example, you wanted to test something else, like you wanted to test 2.5, well, keep in mind the resulting x and y coordinate here would show up in between what I currently have as my second and third coordinate. So the time should still always make sense logically. Alright, but just with these points here. Negative 5, negative 1. That's a little bit off our track here, but negative 5, negative 1 would start off about over here. Negative 3, negative 5. That's around here in quadrant 3. That's our second point. 0, negative 9. That's down here on the negative y-axis. That's our third point. The fourth point I have is 5, negative 13. So about here, that's my fourth point. I will connect these values in order. And I will also indicate orientation to indicate where I'm starting and where I'm going. My first point I plotted was negative 5, negative 1. So I am curving down this set of points. However, keep in mind that 4 is not the restriction on t. T is not restricted to be at maximum 4. I could continue to plug in higher and higher values. And from what I'm now seeing in my trend is that x is getting progressively larger as y is getting progressively smaller or more negative. This trend that I see on the graph as well is likely going to continue. So I will also indicate that by showing that it will go beyond the points that I have plotted. And that would be my entire curve. Starting from this first point and going on infinitely down into quadrant 4.